Welcome to Peer Check. I'm your host, Adam Keating, and today we're talking about what makes hardware so hard and what you can do about it to make it better. My guest is Mark Morreale, our engineer in residence here at CoLab, and honestly one of the best engineers I've met and brightest in the industry. From the work he's done on MRI machines to just how he thinks about engineering from a modeling perspective and what the right way to do it is, not many people care as much as Mark. Mark, welcome to the show.
I appreciate that, Adam. And, great to be on.
So, Mark, I'm going to ask before we get into that, I want to know, like, on the topic of hardware being hard, why have you decided to dedicate, your life to both building hardware and then figuring out how to build hardware better? Why? Like, you could have chose so many other things.
I mean, as a kid, I was always that kid who took apart my toys rather than playing with them, much to my parents' chagrin. But it's because I was interested in how people managed to put these things together and how they worked. And I realized that what we take for granted in our day-to-day life are things that took a lot of human effort to be able to make a reality. And the more I got into it when I went into college, the more I realized that every single product around us is actually the byproduct of not no doubt thousands of hours of work. And that's what I became fascinated with of how this built world around us came to be. Um, but as I started working, I realized that the problems around hardware are mostly not necessarily the products we're building, but the humans that are trying to build them and integrate them. Is that we can have a lot of great ideas, and I've seen many ideas fail to come to fruition, not because they were bad ideas, but because of the communication that couldn't happen between the team members trying to put these things together. And it's tragic, right? Especially working in the medical industry, I've seen great ideas that couldn't become real products, not because the market wasn't ready, not because they lacked scientific merit or medical merit, but because it was just too hard to accomplish.
Yeah, and I'm curious, Mark, like in each of these different experiences you had, like what are the key things in your mind that makes hardware so much harder to communicate about and so much harder to work on together? Because software is hard too, right? Like software is not a walk in the park by any means, but it feels like it's figured out at a different degree than hardware. What do you think makes the big difference?
I think part of the challenge is that hardware requires a huge commitment to a certain idea that it's hard to walk back from that if you've put a lot of time and effort and resources into this particular idea. And so it leads teams to not want to change a lot of times or not want to let go of things that they've done because they've invested so much into that idea so that at that up until that point in time. And so that's one of the things that makes it very difficult. Is in the world of software, and I've had managers from the software world, do project management for hardware teams, and it was a transition for them because in their world, sprint cycles were 2 weeks, and it was hard for us all to communicate the fact that sometimes it takes a while just to get the drawing out, let alone getting the quote from the supplier, and then getting that piece of physical hardware back into the facility and built and tested. So that was one of the biggest challenges, is that we had to commit to certain ideas, and if these ideas didn't pan out because of a lack of feedback in the beginning or because of some information that we weren't totally aware of, then we would end up having to essentially start all over again. And that's really a tough pill for a lot of project managers to swallow because there's oftentimes deadlines that we commit to, and there's other teams, other stakeholders who are expecting certain pieces of hardware to be delivered. And when things go wrong, it's very hard to recover from that. And so it's always been important to make better decisions early, but it's just not always clear how to do that.
Yeah, you've talked to me a lot about like the S curve. Like the further you get down this product development cycle, the more expensive every single change becomes. And it's not like software. Like, I mean, there is some build up to that for sure, but you can iterate pretty quickly. If you ship bad software, you can pull it back and fix it pretty fast. Once you ship hardware, you're kind of screwed if that doesn't go the way you want it to go. I'm curious from like a PD process perspective. You just said like your manager had a software background. It changed what they thought. I've heard lots of teams talk about becoming agile and like then pushback that didn't quite work. Stage gate not quite working. Like, what is the way to think about product development? How should managers and leaders be thinking about? Is it stage gate? Should I change this? Should I take elements of agile and put it together? Like, how do you even start that conversation inside your org?
I think there's nothing wrong with any of those methods per se, right? Whether it's stage gate, agile, there's other methods that I've been introduced to in the past, but it's all about how they get implemented and making sure that you're not looking at the process from a textbook standpoint. You have to adapt that to the realities of your business. It's oftentimes sort of a cop out where people say, well, we're just going to go agile and we're going to, put up a whiteboard with some, tape on it for Kanban lines and swim lanes and stuff like that, and then just assume that the problem is solved. You have to frame whatever project methodology you're choosing to follow in the realities of your business, and understanding what kind of lead times are you dealing with, what kind of regulatory frameworks are you dealing with, what are the things that you can't change, and then you have to work around that. So in some cases, organizations have to go through a more staged approach because whether it's for funding reasons, regulatory reasons, you have to frame that in the reality of your current business. I think the biggest mistake a lot of folks make is saying, hey, here's a methodology that I read about in a book. We're just going to follow what the book says and move on from there. And it becomes a problem because you almost have people performing the call to authority of saying, oh, well, the safe framework says this, or agile says this, and whatever. And you're abstracting yourself from the current problem, and you're just sort of pointing to some map and saying, well, this is the way it ought to be, and ignoring reality.
It's actually interesting because, like, so I worked at Reflection Medical, and when I was there, we were thinking, I think they were thinking about it in the way you're describing, like taking elements of, agile and building it into something that had a really long compliance timeline for a medical device. But I think the part that they took that I remember working well at that point was like they did like a couple stand-ups a week, so that the communication was just happening more frequently. And like that's not always the right thing. Like we found, I think here at CoLab, that doing the big broader stand-ups were becoming overwhelming. Too many people, too many different concepts. So now smaller stand-ups happen and that works. But I think it's taking little bits and pieces, like you said. My question to you though is like in that mindset, how do you not just get spaghetti? Like how do you not just get like an absolute spaghetti process that nobody understands at all? Like what's the boundaries to put in place for someone trying to experiment with this?
I think it's a good question, and I think it's important to give all the stakeholders a chance to provide feedback on the process itself, and recognize that just because you started to roll something out, it's not the final word. Um, the processes themselves need to be evaluated, and you need to be able to, first of all, measure, is this process itself even effective? Are we doing things better, or are we actually doing ourselves a disservice by continuing to implement this? And it speaks to the commitment problem with hardware before, is that sometimes when you decide to follow some specific project management methodology, a lot of times people don't want to walk back from that. They're afraid to, I mean, not going to lie, I've seen people who are just afraid to admit that they've made a mistake. That what they were doing was not quite right. The PLM tool that they've chosen was not correct, or something like that. And they needed to kind of swallow their pride and acknowledge the fact that we need to change. And I think that's the biggest thing that leaders need to recognize, is that the people who are responsible to implement these processes, they're the ones who are going to give you the most important feedback about the process itself. If it's not working, they're going to say so in the beginning, but what unfortunately happens is that if those team members aren't listened to early on, then you just end up with complacency, and you end up with, there's a term that's happening right now called quiet quitting, where people are just sort of doing the minimum of their job and they don't care anymore. They don't care to point out that there is a flaw in the process, because oftentimes people just find that it doesn't matter what they say, right? And that's a tragedy I've seen time and again in tech companies, where somebody would be given the task of implementing some new process. The process has definitely good merits, but when there are issues with it, they're not quite interested in hearing what could be done differently. And that's something that needs to change in hardware companies, because it's the likelihood of one getting the new process and product development methodology correct the first time, slim to none. But there is definitely an opportunity to iterate on that based on the feedback that you get from your team. And that's the key, is listening to the team.
Yeah. Before we get into like supply chain and some of the other things that are hard about hardware, I just wanted to go back to a word you said, and I think it comes up here again. You use the word effective and also not being like married to what you've done, being okay to say you made a mistake. I think one of the things that I see a lot is that when people think about improving their process, their mind immediately is like, how do I take this existing process and just make it better versus thinking about should we be doing this? Like if you think about like lean, like the lean mindset for manufacturing and how you're building that, the whole thing is like challenging and questioning, should you do this or not? I don't think that happens with product development. I think we assume it's like great example I think we deal with every day is drawings. The efficient thing to do would be not to do it on paper, but do it in your browser or use CoLab or whatever. The effective thing might be to not do drawings at all, to move towards model based. How do you think about effectiveness and efficiency in the lens of like what you just said? Process, iteration, not just product development iteration.
And speaking to what you said, it's definitely true is that people are trying to take their existing process and adapt it, right? And we see this with engineering drawings, right? Is that people have been trying to find ways to continue to use engineering drawings, and we've been building standards that, in many ways, the legacy standards of drawings are holding us back. The legacy standards of engineering drawings were designed for human consumption, to be able to communicate information about 3D objects for humans to read. But what we're trying to do with model-based is to try to rethink that from the ground up and make it so that machines primarily can be the consumers of this information, with humans making the decisions along the way. Um, and I mean, there's a quote that I think is attributed to Henry Ford. I'm not totally sure, but when people had asked him, or he had said, if I had asked my customers what we wanted, they would have just said they wanted a faster horse. And this is the same kind of problem, right? Is that oftentimes the users or the people who are implementing these product development processes are really just looking at what's there, and then, like you say, they're trying to make it faster, better, but at the same time, it's still just more of the same, right? And in order to really get to the next level, you kind of have to drop everything sometimes and say, well, what is it? What is the problem that we're really trying to solve here? Are we trying to make drawings more effectively, or are we trying to communicate about our designs more effectively? And and we've seen this with our customers, is when they start to drop that mindset of, is this just a better way of making drawings, or is it a better way to communicate engineering data? It's a mindset shift that really, we've seen it with our customers, is really what enables that 10x improvement in their productivity, right? It's letting go of the past and moving toward the future.
Yeah, it's a funny thing because like I think about Microsoft Teams. I joke about that all the time, but like as much as people say, everyone uses Teams now, that's a huge behavioral change that then brought people into digital technology who might have been hesitant about it. There's much bigger change that need to happen now because I think the thing that makes hardware even harder now is that the expectations of hardware companies are starting to get closer to what people expect of software companies. You see it in the public market outside of Apple and a couple of companies who arguably are like, a lot of software anyways, and they're really technology companies first. Companies are getting crushed on valuations because they're not producing the same margin. They're not producing the same speed. A new vehicle might take 50, 60 months. Whereas like the new phone, I know there's a difference in complexity here, but like a new phone is coming out, man. It feels like every day there's a new phone coming out and there's a new software update every 5 minutes. It's like those two things are so on opposite ends of the spectrum that now you look at like electric vehicles, for example, what Tesla's done. Every other OEM feels okay. We now need to do 30 to 40-month development windows. Yet at the ground level, we're thinking about making drawings 5% more efficient. Like those two things don't add up.
Yeah, no, it's the amount of productivity increase that is necessary is you're not going to get with small changes, and even then, it becomes a diminishing return, right? If you can start making your drawings 10% more effective, next iteration you're probably only going to be able to squeeze 5%, and after that you're only going to squeeze 2%, right? And there comes a certain point when it's not the process that you're following, it's the things that you're doing that are not effective and aren't going to get you there, right? And it's a good example from automotive manufacturers and this drive towards electrification, right? And it's because no matter what, when you're still a company that has to bang big pieces of metal together to produce body panels and stuff like that, there's going to be realities that you have to acknowledge that it's not like a cell phone, right? Where oftentimes the tooling is small, and it's easier to tool up. It's arguably easier to tool up an assembly line for a phone than it is for a vehicle, right? Because just from the number of components, just the amount of raw materials that's involved, and the number of diverse industries that have to support that vehicle's manufacturing, right? Thinking about what goes into a car, it's not just mechanical components. You think about everything from the vehicle's seats to its climate system to its tires. Everything has a different vertical that has to support that vehicle. Whereas a tech company that produces phones, it's very closely related. And so that's the challenge that I think a lot of these larger manufacturers are facing, is that they're trying to do things like tech companies, but there's a limit to what you can do because of just the type of product that you're building and the way that they're made today. Now, I think these problems can be solved, again, through this more proactive design approach, where you're trying to get people into the conversation earlier, so that way, if you do push this very aggressive timeline, the likelihood of something going wrong toward the end of that 40-month window is minimized, right? Because it's all possible, right? And I've certainly been in projects where I've seen the project schedule laid out at the beginning, and if all went fine, we would have delivered it in time. But it's that big question: if all goes fine, and sometimes, going back to the project manager discussion, we have to suspend our belief of reality just to push that schedule out. But unfortunately, and this is another thing that plagues hardware companies, I think, is that a lot of times the engineers themselves, the developers, don't even believe in the schedule, right? That they have a schedule that's put in front of them, and they're just like, "Yep, I guess that's just going to be. It'll be a conversation for the future of when that's going to slip." And that's a big problem, right? People are knowing this information, they're keeping it to themselves, and they're not raising this early. And that's something that has to change. And that, I think, is one of those large shifts that we have to think about in our development methodologies. It's not just, should we make our drawings a bit faster and that's how we'll get there? It has to be, we need to rethink everything from the beginning. We need to be very proactive with our manufacturers and our tooling suppliers and those who are going to be, doing things maybe 2 years from now in support of this project. But we need to take that into account today, so that way we're not in a world of hurt later on.
Yeah, there's really a pretty clear theme here, I think, that you're coming across is like for hardware in particular, doing stuff early is really important. And I actually would like to dial in there on like the supply chain, like the external part. So I think from an internal design perspective, there's a lot you can do. I think there's a lot of hesitancy about the later stage parts where a lot of the cost and mistakes do happen. It's like, how do you actually build this thing? It's like the hardest part. It's like, how do you actually tool it? You've gone through the, exploration phase of building something. How do you actually go build it and productionize that thing? How do you think about like taking the challenges of what many people consider like a multi-pronged supply chain hell at this point? Because there's one, it's like working across company boundaries is brutal in the first place, so that's hard. Then you layer on the fact that products, components, materials are scarce right now, so the supply chains are like unstable. How should teams think about building stronger supply chains in the same mindset you just talked about from design, like think about rethinking the design process? How should they rethink supply chain?
I think it's important to look at your supply chain as experts in their own right, right? And that's where a lot of these problems do arise, I think, is early in design process, we as engineers tend to we tend to overestimate, I think, our ability to anticipate what's going to happen down the road. Where I may be designing a product that has to be laser cut out of sheet metal or something like that, and I may make some assumptions about how it's going to be fixtured and how it's going to be measured and inspected, and that would lead me to make potentially some detrimental decisions in how that part is designed. Right? What really needs to happen is very early on in the development process, we need to bring in trusted suppliers, or and usually it's more than one supplier, where we let them provide their expertise back to us, and we say, this is what I'm trying to build, and this is what I'm trying to achieve. This is our initial concept. Can you help join the conversation and help us understand what is the best way to go about this to achieve the desired result. What I find is a lot of times the engineering teams are trying to just do it all in many ways of getting these production drawings that would be perfect and flawless themselves without actually consulting a supplier first. And they throw it over the wall to their supply chain team, who then in turn just throws it to their suppliers. And the suppliers might see a whole bunch of, datums and tolerances that may or may not relate to the final function of the part, and they'll just quote you based on what they read. But if you flip that on its head and you say, well, before the drawing is even complete or before the model is even complete, if you can engage these suppliers and say, look, this is what we're trying to build. Can you help me by putting your expertise toward the problem and let me know what the most effective way to do this is? In doing that, you're empowering your supply chain to help you make better decisions for your product. You're letting them provide their expertise that you don't necessarily have, and you're basically letting yourself focus on what you, the product designer, are best at, which is usually interpreting somebody else's requirements for your particular product, right? So it's all about letting everybody bring their best skills forward toward the project itself, and letting people provide that feedback that builds that sort of institutional knowledge around the product, what it's supposed to do, and how to best achieve that. When you do that, I think suppliers themselves will feel more empowered. They'll be part of your process, and they'll help you make decisions that will help make better profits. I don't think very many suppliers are interested in selling you parts that would bankrupt your company, right? They want to sell you your products that will produce an ongoing stream of business, right? Even if they can't make as many or as much money per unit, it's always in their best interest to have that ongoing revenue, right? And so um, that's the key, I think, for supply chains today, is to involve them as a partner, but at the same time making sure that the sort of the keys still remain within your organization itself. You're trying to share just enough information with them so that you can make key decisions about your product without wasting too much time. Because that's another problem, is that people, I think, spend a lot of time trying to solve problems that their suppliers can solve just like that. And that's a big problem, that we need to remember where our expertise lies and bring in those experts who can help solve the problems quickly and effectively.
Yeah, I mean, I think like what I'm taking from this, and I think it is a mindset shift similar to the PD process we talked about. It's like suppliers are not just like a cost game. Like, it really shouldn't just be like go out get a bunch of quotes. And some components maybe, but generally you use the term trusted suppliers and trusted partners. I'm hearing that more and more now from companies where they're basically building like, I would say, extensions of their company that they work more closely with, and you're going to see more and more of that now with the pressure to deliver faster, because it's not all about cost in the sense of like the raw component cost. The cost of picking the wrong supplier, the cost of not working well together, the cost of missing a delivery is way higher than it being 2% more expensive to go with a manufacturer that's a little more costly, in the traditional cost sense. How do you go about figuring out like building that trusted partner network? Like, that is such a important element for that to work. It's the same thing what you said earlier about building trust in the team and the process. It's critical to that feedback. It's critical that everyone feels heard. But how do you do it supply chains so there's not just this like massive risk that you're then going to get gouged on price or something else? Like, what is the way to think about building that network?
I think it's when we're talking about trust of our suppliers, it's all about making sure that they feel that they're being empowered to make the decisions that work for them as well, right? And I think one of these things is it's to move away from the concept of suppliers as a cost center and moving towards suppliers as a value add. When we move away from the idea of cost and we move toward value, right? And this is something that I've observed, in med device industry, is something called value based healthcare, where we're really trying to just help the patient as opposed to the symptoms themselves. And that's kind of the way I would look at this in terms of the product development processes, is that we look at our suppliers as somebody who can really add value to our enterprise. And when I say enterprise, I don't necessarily mean just our organization. It is sort of an environment of multiple organizations trying to build a product, right? And if you look at a supplier as somebody who can add value as opposed to somebody who just is a center of cost, and I agree with what you're saying. In some cases, for commodity products, it's hard to see that additional value that gets added. But for a lot of industries, our suppliers themselves are value adders. And when we start looking at who can add the most value to our organization, it's no longer just this race to the bottom for the lowest price anymore, right? You may have a supplier who costs slightly more than the next, but when you look at the value that they can provide, whether it's in terms of giving you innovative ideas in terms of how to tool this up, how to produce this, how to reduce costs in terms of piece parts, or how to improve value, right? How can oftentimes our suppliers can help us understand what is a better way of doing this, what might be a better material to use, or something like that that would allow us to deliver better value to our customers. And that's something that is usually outside the realm of expertise of our organization. It's something that the suppliers themselves specialize in, and we need to leverage that value that they can add.
Yeah, I think like one of the interesting things that you talked a bit about here, there's a process, talk about like leveraging suppliers. There's like a bit of like a common theme of like really trying to get the most out of the humans who are involved here, like the people who are involved here. And like the last place I want to kind of go with this, because there's lots of pieces you can think through. Thing that you're seeing, you use the term quiet quitting, but there's also like a transition happening. Like if you look at the university level, I went through mechanical when I started in engineering, 2013. Mechanical was the number one degree chosen in the university. By the time I finished, software was the number one degree, and they'd flipped, like completely flipped in terms of ranking. You're seeing that now in industry. People are shifting away from it. Suppliers are like eventually going to go out of business. Like people are moving away. How do we think about fixing that problem? Because that's a huge risk to making hardware way harder. Is if people don't keep investing in it, people stop prioritizing. How do we think about the people side? Given like what you said earlier about PD process, really sounds like it's important to iterate with people. Supply chain, we're talking about leveraging their knowledge. What happens if all that goes away, or at least starts to? Like, how do you prevent that from making hardware impossible?
Yeah,
It's hard.
yeah, and the idea of a brain drain in hardware is frightening, right? Because um, it's about making it desirable for people, almost making it fun again, right? I can relate my personal experience when I started when I started in college way back in 2001. We were the first cohort to use 3D CAD. So previously, classes before us were using 2D, AutoCAD based products, and we were sort of an experimental group. We were using this newish tool called Pro Engineer. It wasn't by any means new by then, but it was new for our school. And the reason I'm mentioning that is because it was a mindset shift where we were no longer making drawings of things. We were making three-dimensional models, and the drawing was a byproduct. And I think that itself has influenced how I viewed engineering from there on forward. I was no longer putting lines on a page. I was building a model of something that empowered me to quickly make a page full of lines, right? That represented that object. And that was fun to me, right? I also saw the power of parametric CAD modeling, where you could, if you build a very robust model, you can, change a few values and boom, you got something totally new. That was actually fun. And it was something that helped put me through university afterwards as a set of skills that I was able to employ. And I think that's something that has to happen again with the new generation. I spent a lot of time talking to people about model-based engineering, which is sort of an extension of the ideas of 3D CAD, but now extending that beyond just geometric models and now into models of requirements, of models of system architectures, models of tests. And how do we tile that back to the models of the products that we're building in one environment? And that's something that they've referred to called the model-based enterprise, where people do feel empowered by the decisions that they can make because they feel they trust that the information that they're seeing is an accurate representation of the full picture, of the full truth. I was in a conversation yesterday with somebody who she was having many arguments with people on their engineering drawings, saying, "Well, there's too many datums. There's too many datums," and And the problem is that these individuals just see these datums as a liability, and they don't see how that connects to the rest of the product. And it's really demoralizing for somebody who's put a lot of work into a drawing to be told, oh, there's too much of this, that, or the other thing. I think that's where model-based methods will help. That the newer generation, they're going to learn to tie the things that they're designing to requirements, to other things that are both upstream and downstream. And just like I found it awesome that I could, change a 3D model by changing a few numbers, here we can now change a full product of design to accommodate different changing requirements. And we can also test those designs and be confident that what we're testing actually satisfies those requirements. That's the promise of model-based engineering, that I think when the newer generations start to think about things this way, they're going to surprise us in terms of what they can accomplish, right? And that's been sort of one of my goals, is helping to promote these methods, because I know that in the future it's about putting these tools in the hands of the subsequent generations of engineers, because that's going to be what gives them their their uh, their superpowers, so to speak, right? In the same way that I was part of the Nintendo generation, that when they put CAD in front of us, 3D CAD, we picked it up very quickly, right? And right now, I used to teach SolidWorks at university. I don't need to anymore, because kids can learn SolidWorks from YouTube, which is crazy, but it's awesome at the same time. And so what we need to do is we need to put these tools in the hands of the new generation, and make sure that the development methodologies that we do can let them do their best work using these models and using the information that is actually there. But it is a huge mindset shift, and I think we need to step out of the ways that we've been doing things historically and think about these new methods. Now, I shouldn't say we have to completely step out of them. We've been working towards model-based methods for the past 20 years, but it's about asking ourselves the question of, do these older legacy methods still serve us, or should we be sort of cherry picking from the more recent things that the more recent successes that we've seen, and understand, is there a better way to do things? Because again, I shudder to think that somebody who's entering university today is going to be spending too much of their time making drawings, because they just don't have to. It's pointless. And um, if they spend too much time doing that, then we're going to see even more of a brain drain, because they're going to recognize there's better ways of doing things. They're going to jump to the software world, where things don't seem so ridiculous, and just to get things done. I've been in situations where just to share a drawing with my supply chain engineer took a week, and they didn't have a computer that could open the CAD file, and so they had to set up a meeting with another manufacturing engineer just to open the drawing. That is not going to fly for the next generation of engineers, and we need to rethink this today
Yeah,
to fix it.
it's already not flying for even folks who would be like their career staked in, say, drafting, for example. Like, I think there's become, there was resistance to change, and there still is to some degree. But you start to see these people latch onto, like I brought up Microsoft Teams, you start seeing them latching onto digital tools. Once they see the change, they're like, I never want to print this stuff off again. I don't want to spend my time. They have value they can add in a different place that is like take their per unit of time, they're adding more value to the business. And like you said, like for the next generation, like they grew up on cell phones, which like when I went through high school, I got one in the very end. But like the difference that's going to have in terms of how people expect to work together, like 7 day turnarounds on communicating something is like a foreign thing, right? It'd be the equivalent of like walking something between St. John's and Toronto is how it would feel. But that still happens, right? Like think about it. Kids are going to be home and going to university, building stuff uh, together, real time Google Docs, and then they're going to go work and they're going to work in systems where it might take like 2 weeks to just get the latest information. Not going to fly. What I guess my last question for you is like on that side of things, outside of the model based approach, what else should companies be thinking about for that next generation so they actually want to do it? You use the word fun. You're thinking about the trends. You use the example of you going to university and like being able to do something in like a more innovative way. Like what is going to make it so that that next generation of high school kids who are looking at building stuff said, cool, I want to build physical products not just software? Like, what is it that's going to get them there?
I think it's letting them sort of see that they can get from idea to product quickly, right? At the same time, it's not the end of the world if it doesn't work in the beginning. I think getting people there's often been this emphasis towards doing it perfectly the first time, and there's definitely something to be said for that, or trying to get it as right as you can the first time. But what I think yeah, a student or organizations need to be able to do, and this is actually a very holistic thing. It's organizations, education systems. We have to start encouraging students to take these risks in putting ideas out there and feeling safe to do so, right? And feeling that if they're going to enter into an organization where you still have but as they call them, the graybeards, right? Those very senior engineers, you want newer engineers to be able to feel heard and empowered and learn from the senior engineers. Um, but that still involves being able to put their ideas forth and take risks in a way. And I think that's the biggest challenge that a lot of newer engineers face, is that they don't want to take risks by proposing new methods. They sort of want to go along to get along, so to speak. And we need to create environments for and it's not just new engineers. It's even engineers who've been there for 5-10 years, who feel that their voice is not being heard still, because someone who might be there for 25-30 years takes all the air out of the room. That I think is going to be a huge or very important shift for hardware companies. We're facing a huge retirement right now, as the baby boomers are all reaching definitely retirement age, and the generations that followed are starting to reach into their more senior roles. It becomes a lot harder for somebody who's in a junior position to speak up and put their ideas out when they're just trying to do things the way that things have been done previously. I think that's the key, is making sure that organizations feel that they're a safe place to try something different. And even if it doesn't work, it's all about how does the organization handle it after that? How do you perform a good retrospective and learn from these things? Because otherwise you're going to have a whole generation of engineers in a few years who won't quite know what to do because all the institutional knowledge is left. And so that's the key, is just making sure that people are encouraged to take risks. And I gotta admit, we live in a world right now where I mentioned YouTube and learning CAD is a thing, but for a few $100s somebody can also go and buy a 3D printer. And that's one right there, that you can try ideas, and it's okay to fail, right? That's the nice thing about this additive and rapid manufacturing that we have today. It's okay to fail as long as you learn from that failure, right? And that's the key, is making sure that we create those environments where people can put ideas out, you can try them, and then if it doesn't work, then you learn from it. Even if it's a partial failure, it's about being able to, as an organization, understand what was good, what was bad about that, and then keep going, roll it into the next iteration.
Yeah, well, there's something interesting, like this whole theme. I think it comes back to something we talk a lot about, which is culture. Um, and like each company's culture is important. Like I always look at the example right now. I think Ford is an interesting example. Like a legacy OEM brings in new leadership, really goes hardcore on the EV train. There is a kickback towards Ford now that people are excited about what they're doing and what they're building. And for a long time, for the last decade probably, people were talking about Tesla only, talking about Rivian, talking about Zoox, talking about Lucid, right? But I think what like the summary of this whole conversation is, I think hardware is hard, but there's like a massive cultural shift that is needed, not just for the companies, but like for hardware. When it comes back to people, when it comes back to supply chain, when it comes back to process, and it's going to happen one way or another. It's just a matter of how ugly is it. And I think if we just embrace it, it can be a really beautiful thing, man. There's so many things that need to be built, that are just being held up by bureaucracy and like the way we used to do it. You use that example of like go along to get along. Like that's just such a dangerous thing. It makes me nervous. But like taking that and doing that, I think can change the whole game. And I'm thinking we might need a part two of this podcast, Mark, because I got a whole bunch more to dive into. But this was super awesome, man. I really appreciate the time, the insight. I also appreciate the work you're doing to get these ideas out there and spending time working with ads, me spending time working with customers, spending time thinking about kids like yourself in 2001 going into Pro E. Well, what is that next thing? So thank you for all you do for the hardware
Yeah,
world.
awesome. Anytime. Appreciate it. Cheers.